How could I be so naive? Is it so hard to believe that you excel?
Okay, today we're going to go through and make an ammonia graph. Remember, ammonia is the uniodized form of, and has the formula NH3. Ammonium is ionized and has the formula NH4+. The ammonia is what can be toxic to aquatic organisms. And the form depends on the pH. And the equation is ammonium plus ammonia equals ammonia plus H+. So what does this mean? It looks like this graph now. So you know the pKa is 9.24. So this tells us that's actually where the pH where this is balanced. And that's right here. So if you look, this is pH on the x-axis. And this is log concentration of the fraction of each. So you set the total ammonia or ammonium equal to 1. And then depending on the pH, you can figure out how much of each there is. So at pH 9.24, there's exactly 50% of each. So they're balanced. But as then the pH drops, you get more H pluses. There's more H pluses. You drive the equation to the left, and you get more ammonium. So that's what we're going to try to make this graph using this data to look at this relationship. And so the equation is ammonium equals ammonia plus H plus. And you solve this by looking up the pKa. And the pKa, this means the minus log of the acidity constant, and Ka is the acidity constant. So pKa is equal to 9.24, or minus the log of Ka equals 9.24, or Ka equals 10 to the minus 9.24. And then if you remember, when you do this, the equilibrium constant, that's equal to the products over the reactants. So it's the concentration of ammonia times the concentration of the H plus over the concentration of ammonium. And these square brackets, it means activity, but we're going to interpret it to be concentration for now. And so here's our equation. Here's our pKs, and how do we solve this? Because look, it's one equation and two unknowns. We want to know how much ammonia or ammonium. What you do is you say they sum to a constant. And to make your life easy, you say the ammonium plus the ammonia equals 1. And then what you can do, you can say the ammonia equals 1 plus minus the ammonium, and you substitute in. So now you have your Ka equals 1 minus ammonium times your H plus over ammonium. Now we can rearrange and solve this for the ammonium. And so you factor through. We just switch around K times ammonium equals H plus. So what we're going to do is we're going to bring this over to the left side. And we factor out the ammonium. And then we rearrange. You get ammonium equals H plus over our Ka plus our H plus. Right? And so how does this work? So the Hudson River usually has a pH of somewhere between 7 and 8. So let's choose a pH 8. A pH 8 means the H plus is equal to 10 to the minus 8. Right? Then we know our Ka is equal to 10 to the minus 9.24. And we just substitute in. So we have the ammonium equals now 10 to the minus 8 over 10 to the minus 2.4 plus 10 to the minus 8. You just solve that, and now you know the ammonium is equal to 0.946, or 94.6% of the total's ammonium. You can figure out the amount of ammonia is equal to 1 minus the ammonium. So you have that as 1 minus 0.946 equals 0.054. And so here's the graph we get. You get your pH, we just showed it, right? Here's the concentration. We know they sum to 1, right? We know from our pKa, they're going to be equal at pH of 9.24. And then we can put this all in, right? So as the pH drops, our H pluses increase, right? Because it's a minus log, right? So this means you have more H pluses, you get more acidic. As you get more acidic, you have more ammonia. Right? It's only at high pHs that you see the ammonia dominate. And what happens if the pH changes, these just interconvert is what's happening in nature. So we're gonna go make this figure. What do we need? So we need this equation. The ammonium equals H plus over K plus H plus. We need the ammonia, it's equal to 1 minus that. And we need our minus log Ka. So now let's go jump to Excel and see if we can do this. Okay, so we are in Excel. And so what I'm going to do, I'm going to put some stuff in. So we know our pKa equals 9.24. Then we know our Ka equals 10 raised to the power of minus 1 times this. Right? And so you get, that's our Ka. So you have your pKa, you have your Ka. Now we're going to want to plot versus pH. We have pH, right? We're going to do pH from 1 to 12. So I'm going to do it by half steps. So 1, 1.5. And if you grab these and you highlight them, right, we should drag them down till we get to 12. So there's our pHs. I'm going to probably make them so they all have the same decimals. Makes it a little bit nicer. Then we're going to want our H pluses. I guess I could put the square brackets there. So H plus. Remember, that's equal to 10 raised to the minus 1 times pH. And there you have it. So now we can drag that down. So we have our H pluses. I'm going to then see if I can get, oh, no, wrong way. Let's get a, right, and see, that's not great because we lose these. So I'm going to make this into, I'm going to make this nicer. Let's do format. Let's do a number. Scientific. Right, how's that? So you're going to do, right, you can, now you can see it. It makes it much nicer. You can see it in scientific format. And now we're going to figure out our NH4 plus concentration. Now if I forget the equations, I go back. Here it is. So it's H plus divided by our K plus H plus. So let's remember that. So it's equal to H plus divided by their Ka plus H plus. And we're going to drag this down, so we're going to need dollar signs on our Ka. Put dollar signs in there. Hit return. And we're going to drag it down. And as you can see, it's within error. It's basically 1 at the lower pHs, higher H plus, and then right it decreases. Now we can get our figure out NH3. Remember, it's just 1 minus this. Ooh, that's a bad equation. Equals 1 minus this. Try again. Right, and that's tiny. And so now we have our information. So now we're going to make our graph. We'll do pH. I'm going to hold down the command. We'll do ammonium, ammonia. And let's go insert chart. I'm going to do XY scatter. Right, but I don't want it with a line. I actually, right, that's annoying. So I'll click on. I'm gonna delete it for a second. So I'm gonna do insert this way. Click on my chart. This way I can choose the chart with the jaggedy lines, and that looks better. But actually, that doesn't quite look like ours because whenever you see these, they always put them on a log concentration. Right. So if you double click here, we can make this logarithmic scale. There you go. Right, because you see it gets very tiny. So look, this is 0.1, so that's 10%. Right, 1%, 0.1%, so it gets tiny really quick. So because pH is a log unit, so it goes quickly. But now let's make this look nice. Nice. I'm going to call this, I'm going to give it a title, log concentration pH diagram for ammonia / ammonium. Okay, put that. And then I don't like having the x-axis, so if I click here, you want horizontal axis crosses at max. You really want it at minimum, so I'm gonna put some really not like 1 e to the minus 10. There we go. I'm gonna move my legend. The only thing I don't like, I'm gonna close this for a second. I don't like having it, now that I wrote ammonium, ammonia, I'm actually gonna write it out. I'm gonna put this ammonium, ammonia, because I can't remember. If we want to do, we could do both ammonium, and H4 plus. So if I do this way we remember, right? H3. This way we remember. We have it right. And now we need to add in our, let's go, you know exactly what's coming. So if we go chart design, we gotta get in our axes titles, primary horizontal, axes titles, primary vertical. I'm gonna make everything. Let's make this thing better. I'm gonna make the font a little bit bigger. That might be a little bit, and we don't need so many on the concentrations. I'm gonna see if we can get rid of some of those. Let's see, number. We don't need so many digits. I'll do 0 decimal places. Let's see if it does it. Yeah, we can do that. So that's a concentration. Excel does not do that well, so that's a little bit annoying. So I'm going to do this. So I'm going to call this log concentration or fraction of each. So it'll look better there. All right, this is going to be over here, pH. I'm going to close this for now so we can see it a little better. Maybe scroll. Another thing I like, let's get the graph looking better. So let's get rid of the grid lines. Grid lines. And then I actually like the borders. Let's put, if we click on it, border, we'll make that a solid. So this takes a couple minutes to get everything black. Let's get these axes right. These what? That axes. No, it's not good enough. Right, so if we click here, let's see if we do it. Line, solid line, see if it does it. Yep. This one, solid line, black. Now looks like, then whenever it is, then I like, for when we have this log, I like to show the minor ticks. Let's see, is it axes we want in here. So if we click in here, we're gonna want, let's see if we can go find them. We're gonna want the tick marks. We're gonna do major type outside, minor type outside. I like minors for like, this way you easily see it's a log graph. I'm gonna click here, we'll put tick marks, major outside for the pH, so that looks nice. For pH, I don't know if we need all those numbers, so for the numbers, maybe we'll go 0 decimal places also. That looks pretty good. So I think that's looking pretty good now. And then usually I get rid of let me get rid of the border around this, the whole thing, because that way it will then, when you paste it, it looks. Now, so look, we have a nice graph that's showing, look, now you can see it, right? At this 9.24, they're equal. At low pH, high H+, so low acidity, when it's acidic, you see very little ammonia and more ammonia. Let me make this a little bit, maybe I'll make, that looks good like this. Yeah, I might put a border on that. There you go. All right, and that's very easy. As you should see, it's very easy for you to do your equations, right? Right. What looked complicated a minute ago was an easy equation. We have it in Excel. We have our graph done. So things are looking good.